All right, so if you look at the first page of your worksheet, it says, draw a picture representing each of the operations below. Make sure the mathematics can be seen in the picture. So I want some sort of picture that represents 3 plus 3 plus 3. I'm not going to tell you how to do it. Whatever, I'm not going to give you any more instruction than that. A picture that represents 3 plus 3 plus 3. So just take a second to draw that. It's not very, don't make it hard. It should be really easy. But draw a picture that represents 3 plus 3 plus 3. So I want it to have some sort of answer where the mathematics is actually seen in the answer. I want both. I want 3 plus 3 plus 3, and I want the answer. And you might be able to do both of them in one picture, depending on how you do it. There really aren't any wrong answers, unless, of course, you write the wrong number of whatever you're doing. But here we have 3 plus 3 plus 3, and we have a final picture. Can you see 3 plus 3 plus 3 in the picture? Yeah. How? 3 what of 3? And how does the organization of the answer demonstrate 3 times 3 times 3? I mean, I could, so certainly that one is 3 plus 3 plus 3 equals 9. This one's a little more organized. Does the organization actually demonstrate 3 sets of 3? How? 3 columns of 3, well, actually it's 3 rows of 3 dots. So this row goes there, and this row goes there, and this row goes there. So we actually see 3 rows of 3. Well, if I asked you to do 4 rows of 3, which I'm asking you to do, instead of 3 plus 3 plus 3 plus 3, I can combine them into 3 times 4. So this is exactly the same thing as 3 times 3. For part B, 3 plus 3 plus 3 plus 3 is the same as 3 times 4. Can I change the answer in part A to create an answer in part B? What would it look like? Three columns of 4 or 4 rows of 3. However, I mean, that's the same picture, right? So we would just take the picture before and add a row to the bottom. And that would represent 3 times 4. Okay, if we look at part C, you can have your paper back. If we look at part C, 4 times 5, could we convert the answer in B, which was, could we convert this answer into an answer for C? How good, that would work. How would you do it, Chad? One more row? Oh, are you saying add a row to the bottom and then a column to the right? Okay. Is there a way to just add columns or rows and not both? Do we already have a 4 here? For what? For rows. So if I have 4 times 5, what do I need to do to change this to be 4 times 5? Add 2 more columns. So if I added 2 more columns of 4, that's my 20 dots. 4 times 5. Unless you're me and you can't add, that's 4 times 5. Thanks. So we can combine addition and turn it into multiplication. How do we combine multiplication? Let's say we had 3 times 3, or 3 times 3 times 3, or 3 times 3 times 3 times 3. How do we combine multiplication? Exponents. So the first one would be 3 squared. Second one would be 3 to the third. The next one would be 3 to the fourth. So addition combines to be multiplication, and multiplication combines to be exponents. All right? Well, they kind of act the same. So 3 plus 3 is 3 times 2. But exponents certainly work faster than addition does. So the numbers are going to get bigger really fast. So if we look at part D, we have 2 to the second. So I'm going to start with my 2 dots. What should I do to my 2 dots? And so put 2 more dots under them. Why? Double them. Because this is 2 times 2. So I start with a double, and then I double it, which gives me 4. Why do you suppose that's called 2 squared? 2 to the second is called 2 squared. It makes a square. With what kind of square? How big is the square? What kind of square is it? It's a 2 by 2 square. It's a square created with 2 as its side length. All right? Well, when we did part A, we turned part A into part B. Right? In part A, we had 9 dots, and we decided to create part B, we just added 3 more dots to it. How can I convert D into E? Double what we have. So I'm going to take the original 4 dots, and I'm going to double it. And that represents 2 times 2 times 2, which is 8. In that picture, do you see 3 doubles? So where was the first double? No, the first double was the original 2 dots. Where was the second double? Creating the 4 dots. And the third double was creating that second set of 4 dots. So in rows, 3 times 4 means 3 rows and 4 columns. But that's because it's addition. You're adding the same thing every time. Notice when you're using exponents, the amount you add gets bigger and bigger and bigger. The first time we added 2, the second time we added 4. And what are we going to add in part F? We're going to add 8. So we take what we have in E, and we double it. And if you think about it, you can actually see 2 to the 4th. You just count the doubles. My original double, my second double, my third double, and my 4th double. And you can see the pattern, how that goes. Is this making sense? Okay, so now I'm moving on to part G. If I start with 3, what is 3 squared going to look like? 9. So I take my original 3 and I do what to it? Not double. Triple it. Why was last time a double and this time is a triple? Because we're using base 3 instead of base 2. So I take my original 3 dots and I triple it, and oh my goodness, it created a square. Imagine that. Yeah, that's not a square. And if you just do a line, it's a lot harder to see the triples. But if you create squares, then it's really easy to see the triples. All right. So if I take my answer in G, how do I get to H? Not double. I triple it. Because every time I'm tripling it. So I take my original 3 and I triple it. $27. Don't do them in a line. Okay? Now, L is going to be tough. So we're not going to draw all the dots for L. But what would L look like? Or is that a J? Sorry, J. I. Yeah, apparently I don't know my alphabet. Or I can't see, or how to count. So if I have, let's say that this represents all 27 dots in H. Yeah. How would I create the rest of I? Not double. Triple it. How do you triple 27? Let's not worry about the number. How do I triple that picture? How many more do I need? 2 more, and where would you put them? Would you put them to the right or put them below? Below, because that's the pattern. We started with 3, and we tripled it. We tripled it going down to create 9. Then we tripled that to the right to create 27. So 81 is actually the answer to I, and that's what it would look like. Another interesting thing to note, how come the squares ended up in D, G, F, and I, and the rectangles ended up in E and H? What's up? Oh, so how come D and G and F and I are squares and E and H are not? Good. So this is third power, and this is third power. 2 and 2, 4 and 4. The odd number ones are going to create rectangles. So is 2 to the 5th, is that going to be a rectangle or a square? A rectangle, and it's going to have 2 of these. Is 3 to the 5th going to be a rectangle or a square? Rectangle. We're going to take all 81 dots and we're going to make another rectangle. What would 3 to the 6th look like? A square. We take 3 of these, one on top of another. Okay? So, I want to review something. You don't need to write this down. If I had 12 and I times it by 3/4, what do you get when you times 12 by 3/4? So it's saying, this fraction is saying, can I break 12 into 4 equal parts? 4 equal additions. Yes, what is 12 broken into 4 equal additions? So 3 plus 3 plus 3 plus 3. How many of those partitions am I going to keep? 3 of them, right? It says take 3 of 4 equal partitions, which gives me 9. Well, 30, and you can do this in your head. 12 times 3 is 36 divided by 4 is 9. Okay. What about this? 25 to the 3 halves. Nope, that's a bad. 20. Let's do. Um, let's do 12. 12 times 3 halves. Can we break 12 into two equal additions? Yes. What are they? 6. So this is 6 plus 6. But how many 6s am I going to keep? 3 of them. I don't have 3. So if I broke it into, I know that the number we're adding is a 6, but I need 3 6s to get the answer. So the answer is 18. So let's do this in our head. 12 times 3, 36 divided by 2, 18. Okay, what about 6 to the 5 thirds? 6 times 5 thirds, sorry. So can 6 be broken into 3 equal pieces? Yes. How big is each piece? 2. So I know that I broke it into 2s. How many 2s do I need? 5. So 2 times 5 is 10. Okay, let's do one more. What about 35 to the 2/5? Well, don't do it the hard way, do it the easy way. Can 35 be broken into 5 pieces? How big is each piece? 7. So if I have a 7, how many of those 7s are involved in my answer? 2 of them. Okay, so Robbie, what it's saying is break 35 into 5 pieces. So I have 7 plus 7 plus 7 plus 7 plus 7. How many 7s do I keep? 2, because it says 2/5. Break it into 5 pieces and keep 2 of those pieces. My answer would be 14. Now, 35 times 2 is 70. 70 divided by 5 is 14. Okay? So now let's look at the multiplication version. So now, go to letter J. We need to draw 2 to the third. So look at your picture for 2 to the third and draw in part J. Yep. Should be 8 dots. Now, before we go on to what's below it, we have to remember, how does this represent 2 to the third? Where are my 3 2's? So remember, this is 2 times 2 times 2. So I should be able to see 3 doubles. So the first double is always just a 2. Where did the second double land? So it's under it. So that's my second double. And my third double is the entire picture. And the total number of dots is 8. Now, if we go back to this, if we have 8 and we times it by 2/3, can 8 be broken into 3 equal pieces? Not unless you wanted to use decimals, right? And we don't want to today. So you cannot get a whole number when you try to take 2/3 of 8. Yes? Yep. Okay. So this doesn't work. But what if we use multiplication instead? What if we find 8 raised to the 2/3? Not times 2/3, but raised to the 2/3. So what this is asking is, can we break 8 into 3 equal multiplications? Is there a number times itself that is 8? 2. 2 times 2 times 2 equals 8. How many of those 2's am I going to keep? 2 of the 3. The bottom number tells me how many to create, and the top number tells me how many to keep. So 8 to the 2/3 should be 4. Because we can break 8 into 3 doubles. First double, second double, third double, and it says keep 2 of those doubles, which is 4. So now draw the picture for 3 to the 3rd. It's 27. Now let's review where the triples are. I start with a triple. I triple that. And then I triple that. Well, it's 3, and then tripling that row creates 2 more rows for a total of 9. Okay, so it's the problem says 27 to the 4/3. Can 27 be broken into 3 equal multiplications? What are they? So 3 times 3 times 3. 3 triples is 27. How many of those triples am I going to keep? 4 of them, but I don't have 4. So and we say add, but we really mean multiply, right? We're going to multiply one more, which is 81. So on my calculator, if I do 27 to the 4/3 power, I get 81. Now just to try to remind you, what is 27 times 4/3? Can 27 be broken into 3 equal additions? 9s. 9 plus 9 plus 9. And I add an extra 9, which is 36. So there's a huge difference between multiplying by a fraction and raising to a fraction. If you multiply by a fraction, you're breaking it into addition. If you raise to a fraction, you're breaking it into multiplication. Well, this one is 27 times 4/3, and this one is 27 raised to the 4/3. So this one is 3 times 3 times 3 with an extra 3. But this one is 9 plus 9 plus 9 with an extra 9. So that's the difference between multiplication and addition. So the next one, 81 to the 3/4. Can 81 be broken into 4 equal multiplications? Well, we know what they are. We just did it. We're on part L. So for part L, you actually have this picture where each one is a 27. So is there a number that we can put in all of those spaces to equal 81? 3. 3, 3, 3, 3. How many of those 3's am I going to keep? 3 of them, because it's 3/4. So what is 3 times 3 times 3? 27. Okay, you don't need to write these ones down. You can just watch. So let's say that I had 25 to the 3/2. Can 25 be broken into 2 equal multiplications? What are they? 5 times 5. So for my answer, How many 5s do I need? 3 of them. So I'm going to put an extra 1. Yeah, we're going to add an extra 1 to the multiplication. So I hope that doesn't confuse you. Okay, that's good. What about 16 to the 1/4? Can 16 be broken into 4 equal multiplications? What to the 4th is 16? 4 times 4 is 16. We only use 2 of them. 2 times 2 is 4, times 2 is 8, times 2 is 16. So it's 4 2s. How many 2s are in my answer? Just one of them. So the answer is 2. Okay. Let's look at 216 to the 2/3. Can 16 be broken into 3, can 216 be broken into 3 equal multiplications? Well, let's try 2. 2 times 2 times 2 is 8. Too small. 3 times 3 times 3 is 27. 4 times 4 is 16. Times 4 is 64. That's too small. 5 times 5 is 25. Times 5 is 125. That didn't work. 6 times 6 is 36. 36 times 6, 216. So you can just test that in your calculator. You can try 3 to the 3rd, 4 to the 3rd, 5 to the 3rd, 6 to the 3rd, and see if it can even work. And by the way, you need a calculator tomorrow, desperately. So this can be broken into 6 times 6 times 6. How many of those 6s are going to be in my answer? 2 of them. So my answer is 36. Okay, your homework for tonight, if you turn the page, we will work the first set of problems tomorrow in class. So we will do 1 through 5 in class. I want you to do 6 through 13. That's your homework tonight, 6 through 13.